Question number 11. Tan 25 is equal to P. That implies tan 245 plus tan 335 by tan 205 degrees minus tan 115 degrees is equal to, first option, P square minus 1 by P square plus 1. Second option, P square plus 1 by P square minus 1. Third option, 1 minus P square by 1 plus P square. Fourth option, 1 plus P square by 1 minus P square. We are given tan 25 is equal to P. Tan of 245, can we write it in terms of P? Yes. What is it? Tan 270 minus 25. What is tan of 275 minus theta? Now this lies in the third quadrant. In the third quadrant, tan is positive, so it will be cot 25. Because it's an odd multiple of 90, it changes to its cofunction, so we get cot 25 there. Okay, and that is of course 1 by P. What about tan 335? Tan of 335, which multiple of 90 is this close to? It's close to 360. So tan of 360 minus 25. Now this falls into the fourth quadrant. Fourth quadrant, the tan is negative. Does it change to its cofunction? Even multiple of 90 doesn't change to its cofunction. So what do we have? A minus tan 25. So that will be minus P. Okay. So here, and then what you have is tan of 205 is what you require. Tan of 205, which multiple of 90 is it close to? Tan 180 plus 25. Tan of 180 plus 25, that is, it falls again into the third quadrant. Third quadrant, tan is positive, doesn't change to its cofunction, tan 25 it is, which is again P. What about tan 115? Tan 115, that is tan of 90 plus 25. 90 plus 25, odd multiple of 90, so it should change to its cofunction. What is the cofunction of tan? Cot. So, but in this quadrant, it lies in second quadrant. Second quadrant, tan is negative, so you're going to have minus cot 25. That is minus 1 by P. Okay, so we have, therefore, coming back to the problem, what we were asked in the problem was tan 245 plus tan 335 divided by tan 205 minus tan 115. This was what was asked. The options are all in terms of P. So let's look at what we have. Let's plug in all the values that we have obtained here. Tan 245, 1 by P, minus tan 335 plus tan 335. What is that? Minus P. Tan of 205. Tan of 205 came out to be P. And tan of 115, that comes out to be minus 1 by P. Minus of minus, so that makes it plus there. So that makes it 1 minus P square by, here minus of minus will make it plus, P square plus 1. So by P cancels, and you have therefore 1 minus P square by, this P got cancelled, and you have 1 minus P square by 1 plus P square, which is clearly in the option 3. Option 3 is correct. Let's move to the next question. Question number 12. A cos theta is equal to B sin theta, comma, A cos cube theta plus B sin cube theta is equal to sin theta cos theta. That implies A square plus B square is equal to what? First option 1 by 2, second option 1, third option 3 by 2, fourth option 2. Now this problem can be handled like this. We can put some value to theta and get relations between A and B and find the value of A square plus B square. because that is independent of theta there. A square plus b square, you find that it is coming out to be independent of theta. So you can give some value to theta and then find out this. Okay. Now that is one approach. So what is it? Method 1, substitution method. Substitution. Put theta equal to 45. If you put theta equal to 45, we will get A to be equal to B, because cos theta is 1 by root 2, sin theta is also 1 by root 2, so you will get this cancels and A is equal to B, the first equation. Now coming to the second equation, A cos cube theta plus B sin cube theta. A cos cube theta, what is cos 45? 1 by root 2 cube, plus B sin cube theta, that's also 1 by root 2 cube, is equal to sin theta cos theta. What is sin theta cos theta? 1 by root 2 into 1 by root 2. So that makes it 1 by 2. So what we get here is A by 2 root 2 plus B by 2 root 2 is equal to 1 by 2. So this 1 by 2 can be cancelled. So what you get is A plus B is equal to root 2. But you already have found that by this substitution, we found that A is equal to B. So what do we have therefore? 2A is equal to root 2. So what is A then? 1 by root 2. What will be then? A square plus B square, that makes it 2A square. So what is 2A square? 2 into 1 by 2, and that is 1. So the value of this A square plus B square will be 1. That was method 1, where we went for substitution method. Let's go by the general method, method 2. What we'll do is we'll try to eliminate theta from these two equations. A cos theta is given to be B sin theta. So what's the best thing that you can do here? We can go for tan theta, divide by cos theta. Tan theta will be equal to A by B. Tan theta is A by B. Now this A cos cube theta plus B sin cube theta is equal to your sin theta cos theta. Let us divide throughout by cos cube theta. So what do we get? Dividing by cos cube theta, we'll get A plus B tan cube theta is equal to sin theta cos theta divided by cos cube theta. That makes it sin theta by cos square theta. So this further we can write it in the form of secant theta tan theta. Okay, right? Because sin theta by cos theta will be tan theta, and 1 by cos theta will be secant theta. So A plus B tan cube theta is equal to secant theta tan theta. Now, but what is tan theta? Let's substitute that value, A by B whole cube. And this tan theta also we can write it in the form of A by B. Okay, now we find that this is equal to A by A cube by B square, because this one B can be cancelled and you will be left with a B square here. A by A cube plus B square, secant theta, A secant theta by B. Alright. Further, there is a common throughout. We will cancel out that A. So we will get 1 plus A square by B square is equal to secant theta by B. Okay. But what is this? I can say A square plus B square by B square is equal to secant theta by B. Now let us look at let's come back from here. What is secant theta from here? What is secant theta? 1 plus tan square theta under root. 1 plus tan square theta under root. That makes it 1 plus a square by b square under root. So 1 plus a square by b square under root. That gives us root over a square plus b square by b. Okay. Right? So what is secant theta by b now? That is root over a square plus b square by b square. Now call this as 1, call this as 2. From 1 and 2, what do you observe? We observe that a square plus b square by b square is equal to under root over a square plus b square by b square. So this b square cancels, and what do we have here? We can cancel out that root of a square plus, we can get that root over a square plus b square is 1, therefore a square plus b square is equal to also 1. So that is the option that we have got by substitution as well. So option 2 is the right answer, and this we have obtained in two methods, one by substitution method, other by direct elimination method. Let's move on to the next question, question number 13. If an is equal to cos alpha power n plus sin alpha power n, then 2 into a6 minus 3 into a4 is equal to, first option 0, second option minus 1, third option 3, fourth option 2. Now again we can do this problem by substitution method, because you see that all the options are independent of alpha there. So maybe we get the same value for different values of alpha. So put alpha equal to a simple value, alpha equal to 0 degrees or 0 radians. We can even say that an is equal to, therefore, what is an then? 1. What will be a6? Also 1. So 2 into a6 minus 3 into a4 will become 2 into 1 minus 3, and that makes it minus 1. Okay, so the answer is option 2 is the right answer. Option 2 is the right answer, but that was by substitution method. Substitution method. So let me demonstrate to you how we do it in a direct manner. Now let's see. What do you have? An is equal to cos alpha power n plus sin alpha power n. If you observe here, we wanted a relation between a6 and a4. Maybe we should try to get relation between an and an minus 2. So here we get a motivation from there. So what is this? An is equal to cos power n alpha. I'll write it out as cos alpha power n minus 2 into cos square alpha. That cos square alpha, I'm going to write it as 1 minus sin square alpha, plus the sin power n alpha, sin alpha power n, we are going to write it as sin alpha power n minus 2 into sin square alpha. Sin square alpha, I am going to write it as 1 minus cos square alpha. So what we have here is cos alpha raised to the power n minus 2 plus sin alpha raised to the power n minus 2. If you club these two, that turns out to be n minus 2, because an is cos alpha power n plus sin alpha power n. By our notation, cos alpha raised to the power n minus 2 plus sin alpha raised to the power n minus 2, that is clubbing the first two terms after expansion, we get n minus 2. And then what you observe is we get cos alpha raised to the power n minus 2 minus of cos alpha raised to the power n minus 2 into sin square alpha plus cos square alpha into sin alpha raised to the power n minus 2. What we do is we will take out cos square alpha and sin square alpha common. We take out cos square alpha into sin square alpha common here. So what is it? There is already a sin square alpha term here. So if I pull out cos square alpha, I will be left with cos power n minus cos alpha raised to the power n minus 4, and here I will be left with sin alpha raised to the power n minus 4. And what is this clearly? What is this clearly? This is a n minus 4. So what we have here is a n minus 2 minus cos square alpha sin square alpha into a n minus 4. Okay. Therefore, we can write this way: a n minus 2 is equal to minus sin square alpha cos square alpha into a n minus 4. This thing, a n minus 4. So this is a kind of relation that we have got here. Now what you wanted was 2a6 minus 3a4. So let's see how we can use it here. This is valid for all values of n. So how will I get a6 and a4 here? If I put n equal to 6 in this, I will get a6 minus a4, and n equal to a2, I will be getting a2 here. But what is a2? Cos square alpha plus sin square alpha, which is equal to 1. So maybe it gets reduced that way. So let me simplify using this recursive relation. This is a recurrence relation that you have got. Let us use this recurrence relation and obtain the value of. So what we do is, we will go for 2a6 minus 3a4. I am going to write this as 2 into a6 minus a4 minus a4. But what is a6 minus a4? Put n equal to 6 here. Put n equal to 6 here. What is a6 minus a4? That's going to be minus sin square alpha cos square alpha into a2. But what is a2? What is a2? Cos square alpha plus sin square alpha, which is equal to 1. So I can put that value here. Therefore, this turns out to be minus sin square alpha cos square alpha. So 2 into this, inside the bracket what we have got was minus sin square alpha cos square alpha. Okay. But now what is that? What are you left with? A4. Okay. What is A4? Cos power 4 alpha sin alpha power 4. This we can write it in the form of cos square alpha plus sin square alpha whole square minus 2 sin square alpha cos square alpha. So you will get 2 into minus 2 into sin square alpha cos square alpha here, and minus of 1 minus 2 sin square alpha cos square alpha here. How did you get this one? This one was sin square alpha plus cos square alpha the whole square. Okay, so we could write this in that form. So what do you have? This minus 2 sin square alpha cos square alpha, a minus of minus, this term and this term will cancel, and you are left with a minus 1. Now this is what we got by substitution method also. 2a6 minus 3a4 is therefore is equal to minus 1. Okay, so therefore right option is option 2 is the right answer. This is what we have arrived at by substitution method. That was quick. So let's go for the substitution method wherever possible in the problems involving trigonometry, if the options do not involve any trigonometric ratio, any angle. So they are independent, and independent of alpha or independent of theta, options are like that. Then we can go for a substitution method. That will make things quick. Next question, question number 14. If sin theta and cos theta are the roots of the equation px square plus qx plus r is equal to 0, then q square minus p square is equal to, first option 0, second option minus 2pr, third option 2qr, fourth option 2rp. Now sin theta and cos theta are roots of the equation px square plus qx plus r equal to 0. That's what is given to us. So let's go for the sum of the roots. Sum of roots. What is that? Sin theta plus cos theta. What is sum of roots of the quadratic equation? Minus of the coefficient of x by coefficient of x squared, that is minus q by p. Product of the roots is a constant term by the coefficient of x squared, that is sin theta into cos theta is therefore equal to r by p. Okay. Now, how do we eliminate theta from these two? You observe that if you squared this and subtracted 2 times of sin theta cos theta, you will get sin square theta plus cos square theta. So, sin square theta plus cos square theta we know is equal to, that's 1 we know, but how do I get sin square theta cos square theta from here? That is sin theta plus cos theta the whole square minus of 2 sin theta cos theta, that is equal to 1 here. Okay, but what is sin theta plus cos theta? Minus q by p. So that makes it minus q by p the whole square minus 2 into r by p is equal to 1. So that gives us q square by p square minus 2r by p is equal to 1. So clearly from here, taking the LCM, we have q square minus 2rp is equal to p square, and cross multiplying, taking the LCM and cross multiplying, we have therefore q square minus p square is equal to 2rp. Now that is clearly seen in the option 4. So q square minus p square is what you wanted, therefore option 4 is right. Option 4 is the right answer. Let's move to the next question, question number 15. If cos x plus cos square x is equal to 1, then sin x power 8 plus 2 sin x power 6 plus sin x power 4 is equal to what? First option 0, second option 1, third option 2, fourth option minus 1. Here cos x plus cos square x is equal to 1. So which implies that cos x is sin square x. We have an expression sin power 8x plus 2 sin power 6x plus sin power 4x is equal to, find out. Okay. Now what is sin square? Let's write it in terms of, let's write this in terms of cos x, because that will reduce to lower powers. So sin x power 8 we can write it as cos x power 4. And here we can write this as 2 cos cube x. And here we have cos square x. So this is clearly in the form of cos square x whole square plus 2 cos square x into cos x plus cos x whole square. What is it in the form of? It's in the form of a square plus 2ab plus b square. Okay, so it's clearly cos square x plus cos x the whole square. And what is that? That's 1. So cos square x plus cos x is given to be 1 for us. So 1 square, I have it to be 1. Therefore the right option is 2. Option 2 is the right option. Let's move on to the question number 16. Cos square 1 plus cos square 2 plus cos square 3 degrees plus so on cos square 90 degrees is equal to, first option 0, second option 1, third option 45, fourth option 89 by 2. So we are asked to find out cos square 1 degree plus cos square 2 degrees, cos square 3 degrees, so on up to cos square of 90 degrees, the value of this. Now 1 and 89 are complementary angles. Cos square theta plus cos square of 90 minus theta will be 1. So what we'll do is, we will club cos square 1 with cos square of 89. Okay. So the first and the last but one. Cos 90 is anyway 0, so we'll leave that. Okay. Then plus, we will club cos square 2 plus cos square 88, last but 2. What is cos square of 88? Cos square of 90 minus 2. That makes it cos square 2 plus sin square 2. So that will become 1. So how many such pairings can we have? We will see, when you leave out this 90, we will have 89 terms, 1 to 89. But they get paired like this. What will be the last pair we'll get? Cos square 44 plus cos square 46. So we get 88 terms paired this way. 88 terms paired into 44 pairs. So we get 44 pairs. This is 44 pairs. And each pair gives us a value 1. So this is 1, this is also 1. So how many ones we have? 44 ones. And now what do you have? The last, what is the term that is left over here? Cos square 45. Cos square 45 is left over. What is that? So that comes out to be 44 times 1 is added up, plus what is cos square 45? 1 by 2. Cos 45 is 1 by root 2, the square of it 1 by 2. So what do we get? 44 into 1, 2, 88, 88 plus 1, 89 by 2. That is the answer. So 89 by 2 is the answer, and the option clearly is appearing. This option 4 is the right answer. Let's move to the next question, question number 17. 1 plus sin A into 1 plus sin B into 1 plus sin C is equal to 1 minus sin A into 1 minus sin B into 1 minus sin C, and each is equal to k. Then k is equal to, first option, sin A into sin B into sin C. Second option, plus or minus cos A into cos B into cos C. Third option, plus or minus secant A into secant B into secant C. Fourth option, plus or minus cosecant A into cosecant B into cosecant C. What have we given? 1 plus sin A into 1 plus sin B into 1 plus sin C is k, and 1 minus sin A into 1 minus sin B into 1 minus sin C is also k. So what we'll do is, we'll just multiply these two. We'll multiply here. What do we get? 1 minus sin square A, multiplying, taking the product of this two, 1 minus sin square A into 1 minus sin square B into 1 minus sin square C is equal to k square. K into k, k square. So what is that? Cos square A plus cos square A into cos square B into cos square C. And that is clearly k square. And here, which in turn implies that k is equal to plus or minus cos A into cos B into cos C. So, and that's clearly appearing in the option 2. Option 2 is the right answer, therefore. Option 2 is the right answer. Okay, let's move on to the next question. Question number 18. 1 plus tan alpha tan beta whole square plus tan alpha minus tan beta whole square is equal to, first option, tan square alpha into tan square beta. Second option, secant square alpha plus secant square beta. Third option, secant square alpha into secant square beta. Fourth option, tan square alpha plus tan square beta. So 1 plus tan alpha tan beta whole square. Let's write this as, let's a plus b whole square. So 1 plus tan square alpha tan square beta plus 2 tan alpha tan beta. A plus b whole square formula. Now tan alpha minus tan beta the whole square is equal to tan square alpha plus tan square beta minus 2 tan alpha tan beta. We are supposed to add these two, adding them. So what do we have? This 2 tan alpha tan beta will cancel when you add. And what will you be left on the right hand side? 1 plus tan square alpha plus tan square beta plus tan square alpha into tan square beta. Now that is clearly, if you observe carefully, it's nothing but 1 plus tan square alpha into 1 plus tan square alpha into 1 plus tan square beta. And that is secant square alpha into secant square beta. Appearing in the option 3 is the right answer. Let's move to the next question, question number 19. Root 3 plus 2 cos A by 1 minus 2 sin A raised to the power minus 3 plus 1 plus 2 sin A by root 3 minus 2 cos A also raised to the power minus 3 is equal to first option 1, second option root 3, third option 0, fourth option minus 1. As we observe here, all the options are independent of A. So what we can be doing is we can go by substitution method. But then what substitution will make things easy for us? You observe that cos A is playing role in numerator there in the first expression and in the denominator in the second expression there. So what we'll do is we will take A to be 90 degrees there. Let's take A to be 90 degrees. Put A as 90. Then the root 3 plus 2 cos A by 1 minus 2 sin A will now become root 3 plus 0 by 1 minus 2. That makes it minus root 3. So this raised to the power minus 3 will mean this raised to the power minus 3, which is minus 3. So what is it I'll get? Minus 1 by 3 root 3. So minus 1 by root 3 whole cube, that makes it minus 1 by 3 root 3. Now let's move on to the next expression. 1 plus 2 sin A divided by root 3 minus 2 cos A. What is that? 1 plus 2 is 90, sin A has to be 1. Root 3, so what is that? Root 3. This will be root 3 here. And so that clearly what you observe here is this is root 3, then that's raised to the power minus 3 will make it minus 3, root 3 raised to the power minus 3. That's again plus 1 by 3 root 3. Okay. So when you add up these two, clearly this is minus 1 by 3 root 3 and this plus 1 by 3 root 3. The sum will be 0. Sum is 0. And that is clearly appearing in the option 3. Let's move to the question number 20. Log tan 17 plus log 37 plus log tan 53 plus log tan 73 degrees is equal to first option 0, second option 1, third option 2, fourth option 3. Log tan 17 plus log tan 37 plus log tan 53 plus log tan 73. This is what we require. What we'll do is we'll club these two and club these two. Now clubbing the log tan 17 and log 73 Why do we club them? Because 17 and 73 are complementary angles. So tan 73 into tan 17 would be 1. So what we get is log tan 17 into tan 73, because log x plus log y is log of x into y. So this is 1. So log 1 I am going to get 0. Similarly, here again we'll get log tan 37 into tan 53. What is tan of 53? Tan of 90 minus 37, that is cot 37. So this comes out to be again log 1. Log 1 is known to be 0, so 0 plus 0 we have 0. So clearly the option 1 is the right answer. Option 1 is the right answer. Next, let's move on to the next question, question number 21. In the triangle ABC, right angle at C, tan A plus tan B value is equal to, first option A square by BC, second option B square by AC, third option C square by AB, and fourth option AB by C. Now, we have a right angle triangle ABC, right angled at C. So this is C, let us say, right angle at C. So the opposite side will be small c, and let us name this as A. So this will be small a. Let's name this vertex as B, this will be small b. We have a convention that the side opposite to a vertex will be denoted by a lowercase letter corresponding to that vertex. Okay, now this is A. What is tan A? Opposite by adjacent, so A by B. What about tan B? Tan B will be now B by A. When you add these two, what is tan A plus tan B? That's going to be A by B plus B by A, and that's clearly A square plus B square by AB. What is A square plus B square but C square? Because it's a right angle triangle, A square plus B square is equal to C square. But A square plus B square is equal to C square, because the right angle triangle, hypotenuse square is equal to sum of the squares of the other two sides. So A square plus B square is C square. So therefore tan A plus tan B is equal to C square by AB, and that's what. So that's clearly appearing in the option 3. Option 3 is the right answer. Let's move on to the next question, question number 22. Under root of 1 minus cos square 200 into cosecant 200 degrees is equal to, first option -1, second option 0, third option 1, fourth option 2. Root 1 minus cos square of 200 degrees. What is this equal to? This is root sine square 200. Root of x square is mod x, we know. This is mod sine 200. So 200 degrees falls in which quadrant? It falls here. This is 200. In the third quadrant, sine is negative. So what is mod x whenever x is negative? Minus x. So it should be minus of sine of 200. Because sine 200 is a negative quantity, modulus, it's a positive square root here. So we need to take a modulus there. Root over x square is mod x. Root x square is mod x. Using that. So mod sine 200. But what is sine 200? That's a negative quantity. So I put a minus of sine 200. Now this is to be multiplied with what we were asked was root over 1 minus cos square 200 multiplied with cosecant of 200. This part came out to be minus sine 200. and we have here cosecant 200. So they are reciprocals of each other, they cancel each other, and you have a minus 1. Therefore, the right answer is minus 1, and that is clearly appearing in the option 1 is the right answer. Let's move on to the next question. Question number 23. If under root of 1 plus cos A by 1 minus cos A is equal to cosecant A plus cot A, then A lies in the quadrants first and second, second option, second and third, third option, first and third, and fourth option, first and fourth. Now what are we given? We are given that root 1 plus cos A by 1 minus cos A is equal to cosecant A plus cot A. Now, first we will get rid of the square root. What we will do is, we will multiply and both numerator and denominator by 1 plus cos A. We will write in the denominator 1 minus cos square A. Because when I am multiplying by 1 plus cos A, it becomes 1 minus cos square A. And here, it is clearly mod of 1 plus cos A by sin A. Sin A. Okay. Now 1 plus cos A, and 1 plus cos A is always non-negative, because cos A lies between minus 1 and 1. So we can get rid of the modulus for the numerator. So we get 1 plus cos A by mod sin A. Now the expression takes two forms depending upon whether sin A is positive or negative. So if sin A is positive, mod sin A can be simply replaced by sin A, and therefore you will get 1 plus cos A by sin A, which gives me cosecant A plus cot A. So, and if it is not positive, that is sin A is negative, in that case mod sin A will be replaced by minus sin A, and you will then get minus of cosecant A plus cot A. But what we are given in this problem is it's being equated to cosecant A plus cot A. So that would happen if sin A is positive. When is sin A positive? For what values of A is sin A positive? It's positive when A lies in the first or second quadrant. So this happens if and only if A belongs to first or second quadrants. So this root over 1 plus cos A by 1 minus cos A can be equated to cosecant A plus cot A whenever sin A is positive. And when is sin A positive? Whenever A lies in the first or the second quadrant. Therefore the right option is 1 is the right answer. Let's move on to the next question. Question number 24. In a triangle ABC, 3 cos A plus 2 is equal to 0. The quadratic equation with the roots are as sin A comma cos A is 9x square plus 3 into 2 minus root 5 times x plus k equals to 0. Then what should be the value of k? First option, k is equal to 5. Second option, minus root 5. Third option, k is equal to 2 root 5. Fourth option, k is equal to minus 2 root 5. So let's see how we go about this. Here in the triangle ABC, 3 cos A plus 2 is 0. So that is given. So cos A is clearly minus 2 by 3. So A has to be, A is an angle in a triangle, so A has to be between 0 and 180. Because ABC forms a triangle, so A is a. Now when is cos negative? In which quadrant can cos be negative? Cos can be negative in second or third quadrant. So but A is an angle of a triangle, so it can't be more than 180. So it has to be obtuse. Angle A is obtuse. We can have only one angle to be obtuse, so other two angles have to be acute. This is acute, this is also acute. Okay, so cos A is minus 2 by 3, and now we are interested in the sin A value. Sin A has to be definitely positive, okay, because A, although obtuse, sin A has to be positive, and that therefore that is 1 minus cos square A under root. So what do we get that to be? 1 minus 4 by 9. That is root 5 by 3. Okay. Now clearly, what was the equation given to us? Sin 9x square plus 3 into 2 minus root 5. 3 into 2 minus root 5 into x plus k equals to 0. Sin A and cos A are to be the roots of this equation, are roots. So what is the product of the roots? Product is sin A into cos A. And what is that given to be? What can be sin A into cos A? The product of the roots is given by coefficient, constant term divided by coefficient of x square. So that is k by 9. But what do you know about the value of sin A and cos A? We have it to be root 5 by 3 into minus 2 by 3, that is equal to your k by 9. So this 9 and this 3 cancel. So what do we have here? K has to be minus 2 root 5. Therefore, the right answer is option 4. Option 4 is the right answer. Let's move on to the next question, question number 25. If cos square theta by A is equal to sin square theta by B, then cos power 4 theta by A plus sin power 4 theta by B is equal to 1 upon A plus B. Second option, 1 upon A plus B this whole square. Third option, 1 upon A square plus 1 upon B square. Fourth option, A plus B. What are we given and what is asked? Cos square theta by A is equal to sin square theta by B. Now from ratio and proportion, we can write this to be also equated to cos square theta plus sin square theta divided by A plus B. That is, this is 1. So cos square theta will be A into 1, we'll use the first and the last. So A by A plus B, cross multiply, A by A plus B. Similarly, sin square theta is equal to 1 minus cos square theta this way, or from here also it's clear, that is B by A plus B. What you wanted was cos power 4 theta by A. So what does that come out to be? A square by A plus B the whole square is cos power 4 theta by A. So one A cancels and you will be left with A by A plus B power 4. Oh sorry, square here. Square here. A by A plus B whole square. Coming to this, sin power 4 theta will be equal to B square by A plus B whole square. But you want sin power 4 theta by B. So divide by B, it's 1 by B. 1 B will cancel. You will have here B upon A plus B whole square. Now adding these two, clearly what do we get? Adding cos power 4 theta by A plus sin power 4 theta by B is equal to A plus B by A plus B whole square. And that's clearly 1 upon A plus B. So one A plus B factor will cancel and you will be left with 1 by A plus B, and that is clearly appearing in the option 1 is the right answer. Option 1 is the right answer. Number 26. If A cos cube alpha plus 3A cos alpha sin square alpha is equal to m, and A sin cube alpha plus 3A cos square alpha sin alpha is equal to n, then m plus n raised to the power 2 by 3 plus m minus n raised to the power 2 by 3 is equal to first option 2a square, second option 2 into a power 1 by 3, third option 2 into a power 2 by 3, fourth option 2a cube. A into cos cube alpha plus, we will take out a common, plus 3 cos alpha into sin square alpha is equal to m. The next information given is a into sin cube alpha plus 3 times of sin alpha into cos square alpha is equal to n. Now from here clearly adding the two, what do we have? M plus n is equal to a into, what do we have? Cos cube alpha plus sin cube alpha plus 3 cos alpha sin alpha plus 3 sin alpha cos square, 3 cos alpha sin square alpha plus 3 sin alpha cos square alpha. It's in the form of cos cube alpha plus sin cube alpha plus 3 sin alpha cos alpha into sin alpha plus cos alpha. Clubbing these two, taking sin alpha cos alpha from common from these two terms, we have this. Now do we see, if we see clearly, it's in the form of x plus y whole cube, x cube plus y cube plus 3xy into x plus y. What is that? Clearly it's in the form of x plus y whole cube. So this is in the form of a into cos alpha plus sin alpha whole cube, and that's equal to m plus n. So what is m plus n raised to the power 2 by 3? A power 2 by 3 into cos alpha plus sin alpha. M plus n raised to the power 2 by 3 will be a power 2 by 3 plus into cos alpha plus sin alpha. Similarly, if you go for m minus n, what do you get? A into cos cube alpha minus sin cube alpha plus 3 sin alpha cos alpha into sin alpha minus cos alpha. So I'll write it as minus of 3 sin alpha cos alpha into cos alpha minus sin alpha. I'll write like that. This turns out to be cos alpha minus sin alpha cube. So when I go for, what do we have now? M minus n raised to the power 2 by 3 will be a power 2 by 3 into cos alpha minus sin alpha. A by cos alpha minus sin alpha. Now when you add these two, what do you get? M plus n raised to the power 2 by 3. Sorry. We have square of it here. M plus n raised to the power 2 by 3 will be a power 2 by 3 into cos alpha plus sin alpha whole square. And similarly, m minus n raised to the power 2 by 3 will be a power 2 by 3 into cos alpha minus sin alpha whole square. So when you add these two now, adding, what do you have? A power 2 by 3 into cos alpha plus sin alpha whole square. Adding the two, what we get is 2a power 2 by 3 into 2 times of cos square alpha plus sin square alpha. And what is cos square alpha plus sin square alpha? Clearly 1. So we have therefore 2 into a power 2 by 3. So I go back once more. What I have done was I have taken out a common in the first expression. So we have a into cos cube alpha plus 3 cos alpha sin square alpha. Again a taken common. Now what are we doing? Adding. We are adding. What is it you observe? The inside this we took 3 sin alpha cos alpha as common. So we got sin alpha plus cos alpha. Now this is in the form of x plus y whole cube. x cube plus y cube plus 3xy into x plus y. So that came out to be this. Now when I take the cube root, I'm not taking the cube root straight, I'm raising it to the power 2 by 3. So you will get a square here as well. So cos alpha plus sin alpha the whole square is equal to m plus n raised to the power 2 by 3. Now m plus n raised to the power 2 by 3. And what is this coming next? Similarly, when you subtract one from the other, we get m minus n, and then raising it to the power 2 by 3, we get a power 2 by 3 into cos alpha minus sin alpha the whole square. Therefore, adding these two now, I just copied this thing here. Adding the two, we have a power 2 by 3 into 2 times of cos square alpha plus sin square alpha, and that is equal to 2 there. So the answer is option 3. Option 3 is the right answer. Let's move to the next question. Question number 27. If a sin square x plus b cos square x is equal to c, and b sin square y plus a cos square y is equal to d, and a tan x is equal to b tan y, then a square by b square value is equal to, first option, a minus d into c minus a by b minus c into d minus b. Second option, b minus c into b minus d divided by a minus c into a minus d. Third option, b minus c into d minus b upon a minus d into c minus a. Fourth option, d minus a into c minus a divided by b minus c into d minus b. Now, what are we given? A sin square x plus b cos square x is equal to c. B sin square y plus a cos square y is equal to d. And also we are also given a tan x is equal to b tan y. Okay. What we do is divide 1 by cos square x. Why do I do this? Observe from the third equation, that is tan x, tan y by tan x is equal to your a by b. What you wanted is a square by b square. So what you want is tan square y by tan square x is our a square by b square. So somehow we must be able to get tan square y and tan square x from first and second equations. So how do I get tan square y from the first equation? Let's see. Tan square x from the first equation. Divide first equation with equation 1 with cos square x. What do we get? A tan square x plus b is equal to c secant square x. That c, I can c secant square x, I can write as c into 1 plus tan square x. Okay, here. From here, tan square x into a minus c is equal to c minus b. Pull the tan square x term this side. So tan square x into a minus c is equal to c minus b. Therefore, what is tan square x from here? C minus b by a minus c. Okay. Similarly, look at the second equation. Divide equation 2 by cos square y. Then what do you get? B tan square y plus a is equal to d by cos square y. That makes it d secant square y, d into 1 plus tan square y. Okay. So what do we have now? Again clubbing the tan square y terms to the left. So tan square y into b minus d is equal to d minus a. Club this term the other side. So what do we have now? Tan square y is equal to d minus a by b minus d. what is our a square by b square? Tan square y by tan square x. So tan square y by a square by b square is clearly tan square y by tan square x. And what is tan square y? We have found d minus a by b minus d. That divided by tan square x, so that makes it a minus c by c minus b. And that is clearly appearing. So now rewrite this equation as a minus d into c minus a, that is d minus b into b minus c. So change the sign here, it comes out to be d minus b by b minus c, and that is clearly appearing in the option 1 is the right answer.